There we go.
What's up, guys? Welcome back to our channel.
Okay, number 3, write an inequality equivalent to the given. It's been a long time since we did this. So remember that the line between that means not greater than or equal to. What's the opposite of greater than or equal to?
Less than.
Less than. So that's just it right there.
What if it was less than or not equal to?
We start showing work on number 7. Number 5, graph the inequality. So this is a kind of a simple inequality. Remember I just put 3 numbers on these, like -3, -2, -1. How do we graph number 5? Open or close circle? Close circle going to the right. X is greater than or equal to -2. Number 7, okay, solve, go ahead and start showing some work on these. What's our one step for number 7? Add 17. There were some easy problems this chapter.
In my opinion.
This is probably before Willow got here though. What?
In my opinion, the only ones that are easy on this chapter is that one problem right there. Like the graphing.
5, how about 7 though?
Yeah.
Okay, -6 plus 17.
11.
Does not say we have to graph this one, so. Moving on. You wish we had to graph it? Number 9, -5z less than 21. What's our step on number 9? Divide by -5. So I'm going to get z greater than. What's 21 divided by -5? -21/5. Geniuses. Number 11, -5. Alright, what's my first step on that one? Subtract 7. -5 minus 7 is? And then if I divide by -3, you get +4 greater than or equal to b. Okay, if we were grading this, do you know how I would say it?
B is less than or equal to.
Right. So if you want to turn it around, you can. You don't have to. But if I was reading the answer, I'd say it like this because it's just like the normal way. B is less than or equal to 4. But both these are correct. Both of them are the same. Number 13. This one's the big one,
Oh yeah.
but not too hard for us.
That's pretty big though. Not good enough.
Okay, on this one, the left, oh, that's kind of nice when you got room over there. That way you can use up all this room. Maybe, Paxton, you should like move back and
Yeah, I know.
sit next to Eli.
Yeah,
So,
you
you
look
better-
a little
you should
old.
Eli
sit
probably
over.
doesn't need an entire table to himself,
I mean,
although he's using like 3/4 of it.
Yeah.
you should see him use a chomp right there. Look at him. He's going like.
He's using all the space he can.
You-
Okay, on this one, the left side and the right side can both simplify a little bit before we move on. How can I simplify the left side over here? Okay, -3 times 5x, -3 times -8. How can I simplify the right side? 5 plus 2. Okay, I could put 7 minus 7x. That would be okay. But I'm going to put minus 7x plus 7. So it looks more like the left side. If I have x's on both sides of the inequality, what do I do about that? Right, get rid of one of them. So over here, how do I get rid of negative 7x? Add 7x. Now it looks normal. Seven minus 24.
Negative 7. It's broke now. It's negative.
Okay, I'm dividing by negative 8. I switch the inequality. What's 17 divided by 8?
Negative 17, 8.
17, 8. Positive. Negative,
Oh,
negative 17 divided by negative 8. Positive 17 eighths.
Oh, it doesn't go back to normal because, let's see.
If we were graphing that, how would we graph that?
Like 17, open circle.
Yeah, I would change it to a mixed number or decimal. So I'll do like 17 divided by 8. And then you know where it was on the graph. Okay. Now what? Word problems?
Yeah.
This is Macy's favorite. I didn't want to do these, but Macy asked if we could do it. I said, okay, fine.
Macy,
What have you done? Why?
that's why no one likes you. I did it.
First of all.
He's kidding.
Oh.
Macy's
Liar.
literally everything. They
Never mind.
Did you actually believe it? It's a joke.
I totally didn't believe it.
Yeah, we did, Macy. I thought you did, Isa.
Okay, on 15, write an inequality and solve. Find all numbers such that adding 15 to 23 times the number is greater than 429. Let's have a volunteer for this one.
I don't volunteer.
Grant volunteers as tribute. All right, Grant. We're adding 15 to 23 times the number. What does that look like?
Oh, this is the problem from last chapter that I was hated. Adding 15 to 23 times the
Yeah, how do I write that part?
number. 15 to 23?
We're adding 15 to 23
Oh, I
times
thought
the
we
number.
just said 223 like last chapter. Or
We're adding
15 plus 20? Oh, I thought that was in that. Oh.
to 23 times the number, or x. X is fine, I don't care what
But
letter.
then greater than
Is greater than
29.
429.
Oh, this one actually looks very nice now. Oh. I don't know why I hate this. Like 429 minus 15.
Minus 15.
Okay. 429 minus 15 divided by. Wait, oh, it would be answer. Divided by 20.
It'd be a good time for a calculator.
You should try doing it in your head. Yeah, the Mr. Jordan special.
18.
Did you look in the book?
What?
What? Mr. Jordan looking in the book? That wouldn't happen.
It's like secretly Mr. Jordan wrote the book.
No, he would never.
He knows it all.
No, he's the creator of math. Sure. He's like better at math than at whatever
That would
his name
be-
is.
He can't even
The
comprehend.
creator of math would be God, so you probably better not call. More like people, it's more like people discover math, guys.
Mr. Jordan,
Oh,
the secret way Jesus.
I see. Wait a minute. Jesus walks again.
It's kind of like nobody invented North America, people
Oh
just
yeah, it's like
discovered it.
whenever Katie said, "Who invented color?" I invented color. There you go. Wow. That's racist. That was
Man, I was hoping somebody wouldn't say that.
Okay. On 16, I'm gonna help you guys, or you're gonna help me set it up, and then I'll let you guys solve it. Okay. So I need another volunteer. It says find the largest integer. What's an integer?
A number. Negative number.
Not necessarily.
Oh, like a number that can be divided into?
Huh?
Below 0.
No.
Above
It's a
zero.
number.
Like a number that's divided
Any
by
number.
or like that
That's a
can be divided.
constant thingy.
That's
So-
negative.
Maybe
Negative decimal. Whatever that.
Oh, a powder.
any
Oh.
whole numbers.
Number.
Okay.
You know the answer. Go down, Vicky. Go. I just want.
it's not.
Alright, all these numbers are integers.
Oh.
Anything that would be on a normal number line is basically an integer. So no decimals, no fractions. There are negatives, but there's also positives and 0. All those numbers are integers. So no, just think no decimals or fractions, just integers. Alright, so our answer should be an integer is what they're telling us. Find the largest integer such that 8 more than 6 times the integer. Okay, who wants to volunteer on this one?
Isa.
Okay, Isa.
Wait, what?
Okay,
That's not how it works.
it says 8 more than 6 times the integer. What should we write for that?
So the integer is like n or x or whatever.
Yes. Shh.
And then, so it's 6x plus 8 or something.
Yeah, 8 plus 6x or 6x plus 8 is fine. 8 more than 6 times the integer, and then what does it say? Is less than the opposite of 42.
So less than negative 42.
Okay, you guys remember a few chapters ago the phrase less than meant minus?
Yeah.
Okay, but if it says is less than, that's the less than symbol. And on this chapter, we did a lot of less than symbols, right? So, less than, this is confusing, I know, means minus, subtract. Is less than means that. So basically in this chapter, if you see less than, it's probably going to be is less than. It's probably going to be the less than symbol. Like 5 less than your age would be your age minus 5, right? But if I said 5 is less than your age, that means 5. Whoops. Ugh.
Uh-oh. Microsoft Store? Wait. Mr.
5 is less than your age. Is less than. Anyway, that's enough of that. So, okay, here's the problem on this one. I'm going to let you guys solve it. But it said that we need to use the largest integer possible for our answer. So, what that means is you're going to get an answer something like x is less than, I'll make something up, negative 4.7.
So can it
What's the biggest integer that would work for x? Actually, let me start with this.
like 41?
Let's pretend it said x is less than 5.4. What's the biggest integer that would work for this?
5.3.
Now, what did we say integers were?
Oh.
No, it's 5.
5. 5 is the biggest integer that would work for this. Okay? Our answer on this one's going to be negative because of that negative right there. So what would be the biggest integer that would work for this? Okay, remember negatives are backwards. So what?
Negative 5.
Right, negative 5 is actually less than negative 4.7. Because you'd rather have like negative 5 is better than negative a million, right? Like, talking about money.
That would be bad.
So anyway, negative 5 is a smaller value than negative 4.7. So negative 5 would be the answer if this was what came out. This is not the answer, I just made this up. So you have to subtract 8, divide by 6. And then you're going to get one answer. Like if this was it, I would have put x equals negative 5. That's the biggest integer that would work for this. That's not the answer, that's an example. You guys get it? So basically you're rounding down to the next integer on this one.
If I find out that Mr. Jordan was lying to us that negative 5 wasn't the answer, I would cry in my sleep.
Okay,
You do that anyways.
number 17. Find all the numbers such that the product of 7 and the number. Alright, who else wants to try?
Shannon.
Macy.
Shannon.
Macy.
Shannon.
Yeah, it's because of Shannon.
No.
Being Shannon.
What a
I'm not gonna be racist, Shannon.
Okay, Shannon says the product of 7 and the number.
Are you?
N plus 7.
No,
Aha.
What a
loser.
product is not plus, it's.
Oh, it's multiplication.
So what should I put? Shh, girls. So what should I put?
N multiplied by 7. Or N to 7.
7 in. Okay, that's the product of 7 and the number. And then it says is more than. Okay, is more than is basically is greater than, right? So I'm going to put the greater than symbol. Is more than the sum of 7 and the number. What would that be, Shannon? 7 plus n. Okay. And then I should probably keep reading a little bit. It says, what is the smallest integer that is possible? Yeah, basically, what's the smallest integer that could work? So this is kind of like number 16. We got to find one answer, the smallest answer possible. Smallest integer possible.
Doesn't like
If we have n's on both sides, what do I need to do first?
subtract.
What's 7n minus
6 in.
n? 6n.
Stop. You should make Issa do the next one.
What do you mean?
She just did one.
She
Yeah.
really wants to though. She'll pay you money.
Why do you think I called on you, Shannon? It's because you pointed out Issa.
The answer is fine.
But she really does. She said she'll pay you money. Oh.
What? No, I didn't.
Okay.
I'm broke.
I'm broke.
Alright, what do I need to do now?
Like divide.
You divide.
Okay. 7 divided by 6 is like 1 and 1 6, right?
Sure.
Yes.
What is the smallest integer that would work for this? That's greater than 1 and 1 6.
1.
Integer or
No.
Is 1 greater than 1 and 1 6?
Wait.
2. So this one's just going to have one answer, 2. That's the smallest integer that works. So 16 is kind of like that one when you guys
Did we
go
even
later.
do this?
Hmm?
Did we do this?
No. We didn't, no. We did a few word problems, not many, we did a few word problems, but not with the smallest integer answers. Okay, number 18. Sam makes twice as much per hour as Kathy. This one's kind of a doozy. Okay, that right there, Sam makes twice as much per hour as Kathy, that is we can write that as an equation. How can I write Sam makes twice as much as Kathy per hour? Okay, I'm going to let my variable be S and K. Guess what S stands for?
Sam.
No. Sam's
It's cookie man.
hourly
Sam's.
wages.
Oh, I didn't know
Would
that.
it be W for wages?
No, because K stands for
Her wages.
Kathy's
They don't
hourly
get wages.
wages. Okay, so I can't just use W because we got two different hourly wages.
I have a question.
Yeah.
Are we supposed to write that down?
I'm not gonna make you, but that's important to understand what the variables stand for. It doesn't stand for how much money Sam made last year. It doesn't stand for how many hours he worked. It doesn't stand for his age. It stands for how much he makes per hour. So the first sentence, the first part of the sentence said, Sam makes twice as much per hour as Kathy.
S2 equals K.
Sam's wages is
Oh wait.
twice Kathy's wages.
It's
Okay.
2K?
Sam's wages is equal to twice Kathy's wages. Does that make sense? So far, so good?
Yeah.
Can I solve this?
No.
No. Because if K was like 1, this would be 2. If K was 2, this would be 4, 3, 6. There's infinite number of possible answers right now.
Oh, really?
Not enough information. So let's keep reading. It says Kathy works 3 times as many hours per week as Samuel.
Oh.
Okay. So if we wrote I'm not going to write a variable for this, but if we did this, that's different than these two variables. This is hourly wages, and now they're talking about how many hours they work per week. Okay, Kathy works 3 times as many hours per week as Samuel. And then it says Kathy works 36 hours. I'm going to make a note of that. I'm just going to put 36 hours. And, okay, if Kathy works 36 hours, how many hours must Sam work a week?
70.
No?
12.
Divide by 3. Yeah.
Alright.
Because
Oh.
Because we just said that
I
Kathy
forgot
works
for a
3
second.
times as much
Okay.
as Sam.
I just have
So if Kathy works 3 times as much, you divide by 3. Sam's only working 12 hours. So maybe Sam's a student and you like have a part-time job at Brahms or something.
Do you know Bronze Army?
Yeah, Brahms hires 14-year-olds.
Yeah, my sister is gonna get go to Bronx during the summer.
You should tell her to give me.
Probably get rejected.
Cause she's
You
tall.
should tell her to give me free milkshake.
Okay, we're almost there. So it says the sum of their wages exceeds $480. How much, this is talking per week, how much does each of them make per hour? Okay, how do you figure out how much you're going to make a week? Let's say if you got a job at Brahms, how would you figure out how much you're going to make in a week?
Hourly wage.
Ask your manager.
Right.
Right.
You just
Your hourly wages, so you might work different hours different weeks, right?
You don't
Depending.
get paid.
You do your hourly wages times how many hours you work.
Per, and then.
You guys know what minimum wage is?
It's like 7,
I
yeah.
thought it was like $8.
$7.25.
Oh.
So if you got minimum wage and you work 10 hours that week, you would get $7.25 times 10, like $72.50.
That's quite a little bit.
I'm gonna work at Brahms.
Well,
Hobby
minimum
Lobby
wage,
makes more money.
Brahms probably pays, I'd guess, $10 an hour.
Oh, in that case, sign me up.
Hobby Lobby pays
I'll
like
steal
16.
from one.
Well, I'm just saying,
Go
fast,
there for 6 hours.
if you get a fast food job, it's probably get paid
That's what
$10.
the extended care thing is.
Is it $10?
$10 an hour.
Just a nice, easy number to keep track of. All right. Okay. So it says their wages exceeded $480. How do I represent Sam's wages? Okay. We're going. Shh. Listen. We're going to do his hours times his hourly pay. What's his hourly pay?
S.
S. What's his hours?
S. 12.
12. So he's going to make 12 times whatever he gets paid per hour. How do we find Kathy's wages? 36 hours times K dollars per hour. Okay. How do I total their wages? Add, and it's supposed to exceed $480. So what's exceed mean?
Equal over.
Oh, greater than $480.
Stop.
All right. Is this solvable?
Yes.
That's
unkind.
Okay. You cannot solve a 2-variable equation by itself. Just like we couldn't solve this one, right? Because this could be 1 and 2, or 3 and 6, or 4 and 8. Okay. So for the same reason, we can't solve it like it is.
Yeah.
But we can use a trick. We haven't used this often, but we've used it a couple times.
What's happening?
Darn it, I didn't want that to happen.
Oh, this is a Christian school.
Wait, what happened?
He said darn it. He said darn it?
Mr. Jordan, I'm so disappointed.
Okay, anyways, what we're going to do is we're going to replace the S right there with a 2K. This is called substitution. I'm going to replace I'm gonna replace this S with a 2K.
No, this totally isn't the
Yeah.
So I'm going to rewrite this equation, the inequality, with 12 times, not S, 12 times 2K plus 36K. You guys remember what that's called when you replace something?
substitution.
Substitution. Okay, now I have a one variable equation that I can solve. What's 12 times 2K?
24K.
What's 24K plus 36K?
60K.
60K. So 60K has to be greater than 480. How do I solve for K? 60. 48 divided by 6 is
80?
8.
Yeah.
What does K greater than 8 mean on this problem?
Anything of
K is greater than 8.
What did K stand for?
Kathy's
Kathy's hourly wages. Kathy is getting more than $8 an hour.
Oh, that's pretty nice.
Okay, if Kathy's getting more than $8 an hour, what was the other guy's name? Sam must be, how much is Sam getting?
Why do you say it like
less than 8 times 2.
Times, he's getting twice as much. So she's getting more than 8, he's getting
16.
more than 16.
I want to be Sam.
But who's making more money?
Why do you say like that?
Kathy's making more money because she's working 3 times
The
more.
owner of the McDonald's, they're both working.
Okay, number 19. I'm gonna guess that stands for Ollie. Because it says he needs to have an average test score. So if it's a he, I'm guessing it's an Indian name and
That's the go from the book.
yeah.
His name is Alive.
Okay. Anyway, listen. It says Ollie has test scores of 95, 78, and 93. He needs to have a test average of at least 90 to get an A on his report card. What is the lowest score he can get on his final test and still have an A? Okay, so he wants his test average to be at least a 90. How do you average numbers together?
Add and then divide the number.
Add and divide by the number of numbers. How many numbers are we averaging together on this problem?
3.
No,
4.
4. Why are there 4?
Because it's
Because he's also counting his final test.
Because we're counting the test he hasn't taken yet. We want the average of the 4 tests to be at least 90. So how do we average? We add together
So you're telling me if someone got like 100,
and divide by the number of tests, which is 4. And we want that grade to be at least 90. So how do I write at least?
like eating the numbers and then
Eating?
the line underneath it, greater than or equal to.
Greater than or equal to.
I don't know how to describe the name.
It's called greater than or equal to. So we want his test average to be greater than or equal to 90. What's one step I can do to solve this?
Add 95 to the
We can simplify the top here. What does that come out to?
266.
266 plus x over 4.
What?
266
Girl, you
Okay, we can't do 266 divided by 4. Why can't we? Because all of this is divided by 4, not just the 266. And since I can't really simplify x divided by 4, I could divide separately, but how can we get rid of divide by 4?
Just multiply.
Just multiply by 4. Since all left side is divided by 4, we can just do that. That's going to go away. I would ask the office. What'd you lose?
A book.
what else is there?
Why are you thinking
I get it, lose.
Stop. Stop. That's not funny.
My opinion of Shannon.
Oh,
Okay, what is x greater than or equal to 94? What does that mean on this problem?
It's greater than or equal to.
What does that mean?
Wow.
It's
It
greater.
has to be bigger.
Okay,
Like that's the minimum
Remember-
of like the grade test.
yes, he needs to get at least a 94 on his test.
What?
I need you know. I need to find you. Your computer is better.
Okay, we're gonna stop at 21, so we're about done. 22 inequality statements joined by the word and. What was that called?
And is
Oh, that's
The when we combine the and with the and,
it's like a.
starting with a C.
fine.
Okay,
It's a conjunction.
conjunction.
The line
I think it's so
I was thinking of cookies or something like that.
Okay, 20 is a conjunction. Okay, 21, shh, girls. 21 says the union of two. The union was basically the or version. So what was the or called?
Disconjunction.
Nah, not quite. You're close.
Malfunction.
It's just disjunction.
Oh.
Disjunction.
Oh, I thought you said the opposite of disjunction. I would say conjunction. And that was wrong.
Okay, why don't you do a couple evens and then we'll finish this tomorrow.
Wait, are we?
We're gonna pause.